This video is going to introduce the concept of domain restrictions to simplifying radical expressions. Remember that the domain is referring to the input values, typically the x values, that you are allowed to use in a function. So typically domain is referring to x values. What's going to make this lesson a bit more challenging is that other variables aside from x will have domain restrictions that need to be addressed. The domain restriction rules are the primary concepts with this lesson, meaning that if you are not comfortable with simplifying radicals in general, or power over root, the exponent laws, knowing your perfect squares and your perfect cubes and your perfect fourths, you're going to feel fairly lost throughout these examples you're about to see, because the whole simplifying process of what we're about to go through, that's already been discussed in previous videos. And the focus for today is going to be the domain restrictions and how to properly apply those rules to the end of these simplifying problems. This video is not going to be going into depth with the simplifying process of radical expressions. It's instead going to focus on how to do those domain restrictions. So let's go ahead and get started, and go ahead and pause the video, set up the notes if you haven't done so already. You don't actually need that. Refer to example 3 business right there. But nevertheless, pause the video, set up the notes, and make sure you have the domain restrictions and the rules for when you need absolute value bars written down. I'm going to be talking about these rules throughout the video, but for the sake of having your own notes in a nice location, have this information written down with the little examples over there before we get started. Take a moment to do this now. All right, let's go ahead and jump right into it. And a lot of things today are going to be written out on the spot, so we will be working on these together, starting with number 1. We are going to be simplifying, just like we've done in the previous lesson videos. But we have to state domain restrictions at the end of the problem as well. So let's do the more familiar process, which is going to be the simplifying. Starting with working from the inside out. Ignore the cube root sign, start with your fraction bar. We have an x to the first power that is going to cancel with one of the x's of the x to the 6th in the numerator, and that's going to give us an x to the 5th in the numerator. We also have a y to the 5th canceling with 5 of the y's in the numerator, giving us a y to the 5th. Lastly, the 3 and the 4 from the beginning of the problem cannot be reduced any further, so they just tag along, and we can now put the cube root symbol in front of the entire problem. Now, we can do a little bit more simplifying here. Remember that the x to the 5th power, that is going to represent an x cubed and an x squared that we are taking the cube root of. And since we can make one grouping of an x cubed, we're going to be allowed to take a single x. Let me actually just change that color there. We're going to be able to take a single x out of the radical sign and move that to the front for our final answer. The x squared would have to stay under the cube root sign. The exact same thing is going to happen with the y to the 5th power. We are taking the cube root of y to the 5th, which can be expressed as y cubed times y squared. And again, we are taking a single y out of the cube root sign because we could make one grouping of y cubed. So there is a single y that comes out. The remaining 2 y's and the 2 x's and the 3 and the 4, all of those are going to stay under the cube root sign with the x squared and y squared going in the numerator. And let me just back that up so I have a little more room. The 3/4 would go there first, and then the x squared and the y squared. So this very odd looking answer is the correct answer. And that is just the simplifying part. That's what's been discussed in the previous lessons. And if that is something that was over your head, it's a very strong sign. You got to go back and rewatch the other videos where the simplifying process, specifically what is here in purple, that's going to be broken down a bit more. What we are now going to get to is the domain restriction. So I'm going to put DOM for domain, and the domain is going to be, let's take a look at those restriction rules. A variable in the denominator cannot be equal to 0. Look at the original problem. I'm going to erase some of the work here. The original problem, we have variables in the denominator. Now, even though there aren't variables in the denominator for the final answer, there's only a 4 down there. In the original problem, because there were variables in the denominator, we're going to go ahead and say that x and y are not allowed to be equal to 0. You can't have a 0 in the denominator. You can just look at that example right here where y is not allowed to be equal to 0. You can't do something like 3 divided by 0. You could try putting that into a calculator, but it will say error because it just violates the laws of fractions, and we're not here to get into that. Just know you can't have a 0 in the denominator. The second domain restriction, a variable must be greater than 0 if the index is even. This might be an important thing to jot down, but the word index is just talking about the root. It's the same meaning. So the index of number 1 is 3. The root is 3. Those words mean the same thing, and you should definitely write that down if that is something you hadn't picked up on yet or heard of yet. The index is the same as the root. Same exact meaning, just different words. So, if the index is even, then a variable must be greater than 0 underneath the radical sign. And that is not a problem in number 1 because the index was 3, and 3 is an odd number. The index being even makes that rule have to apply. And then the last domain, or not even a domain restriction, let me erase more of this work. Absolute value bars are going to be making an appearance in this lesson, and absolute value bars are only going to be a factor if the index is even, and that's going to come up on some of the later examples. Again, we had an index of 3, so we're not going to need to worry about the absolute value bars, but that's something that's going to come up a lot with this lesson. It might be worth your while to have a star or a highlighter over those domain restrictions and the absolute value. So the only thing that is a domain restriction is that x and y cannot be equal to 0 because they were in the denominator. All right, let's take a look at number 2 right now. So in number 2, we, again, work from the inside out, but you don't even have a fraction to deal with. You just have the cube root. The index is 3, the cube root of 16x to the 6th, y to the 11th. So we need to remember that 16 has a perfect cube that divides it, and that would be the number 8. 8 is a perfect cube that would multiply with 2 to make 16. So you can rewrite 16 as 8 times 2 with the cube root sign. And let me just extend that cube root a little bit more. We have an x to the 6th power, and 6 is divisible by 3, so we are good to go right there. But we have a y to the 11th, and since the closest multiple of 3 to the number 11 is going to be the number 9, and then that leaves an extra 2 y's left over, giving us 9 plus 2, giving you 11. And if that was something you did not understand, then again, from a previous video, that concept is talked about a bit more. So let's go ahead and now take the cube root and simplify what we can. The cube root of 8 is going to be 2. We have the cube root of x to the 6th power. You're just taking that number 6 and you're dividing it by 3. So that's going to be an x squared. You're going to do the same thing with the y to the 9th power. We're going to take 9 and divide that by 3, and that's going to give you a y cubed. Lastly, the 2 and the y squared that are still under the cube root sign, we can't reduce those any further, so they're just going to tag along for the final answer and be the cube root of 2y squared. And that is the simplified version of our answer. Again, this is not the heart of the lesson. The main part is talking about the domain restrictions, and that is what will now be addressed. So let's take a look at our domain restrictions. You cannot have a variable in the denominator. Well, the original problem didn't even have a denominator. It wasn't a fraction, so we don't have to worry about the first domain restriction. The second domain restriction, a variable must be greater than 0 if the index is even. Well, the index was 3, and that is an odd index. So we do not need to worry about the second domain restriction. Lastly, if the index is even, we have to introduce absolute value bars, which has not yet happened in this problem set because that index is again 3. So the domain restriction is that there isn't any. The domain would therefore be all real numbers. Let's take a look at one that is going to have the absolute value rule come into play. And let's just go to the next problem. Take a moment to set up number 3 and leave some space for number 4. Pause if you have to. And okay, here we go. So in number 3, let's simplify first by doing the procedures that we've been working on with some of the previous lesson videos. We are taking the square root. We need to look at the 12 and go, what is the perfect square that divides the number 12? It's not going to be 6 times 2. It is going to be 4 times 3. And that is what we're allowed to take the square root of. We have an x right next to that, and that is an x to the first power. There is nothing we can simplify there. We have a y to the 6th. That's going to simplify nicely. And we have a z to the 4th power, and that is also going to work well when we have a root of 2. So let's continue with the simplifying. We are taking the square root of the number 4, so that gives us 2. We are able to take the square root of y to the 6th by just doing 6 divided by 2, and that would be y cubed coming to the front of the radical. And then we have a z to the 4th, and 4 divided by that root of 2 is going to be 2, so a z squared would move to the front, and then what we have left over, the 3 and the x, will stay under the square root sign. And we have our simplified answer, and now we can get to the domain restrictions. So again, if that was a little too fast, go back and get example practice from the other videos. Domain restrictions, let's go ahead and set up the word domain. And let's remember, in fact, we can just go back a page to look at those previous rules. A variable in the denominator cannot equal 0. Well, in this problem, we did not have a denominator. We had a problem that was no fraction at all. So, skipping that, let's look at the other domain restriction. A variable must be greater than 0 if the index is even. So we have an even index. The index was 2. So, take a look at your variable. We have underneath the square root sign, there is an x. And that x, since it is under the square root sign, that means x has to be greater than or equal to 0, because if x were not bigger than 0, if x were, let's say, equal to -2, then if you were to plug -2 into that radical right there, 3 times -2 is -6, and you are not able to take the square root of -6 in the real number system. Yes, you would get an imaginary answer, and it would be I times the square root of 6, but we are not discussing imaginary numbers in this lesson. We are just assuming that negatives cannot be square rooted when the index is even. So this is a situation where, because the index is even, so if everything that has been set up until now, you're not understanding it, it's too much for you to follow, then here's the bottom line. If the index is even, if it is an even number where the root is positioned, if that is even, then anything under the radical sign at the end of the problem, it's got to be greater than or equal to 0. It can't be a negative value. That's the point. And then, of course, after saying that, if for some reason it were like, I don't know, an x squared, and we'll get to that in another example. Let's just run with that for right now. All right, number 4. And the absolute value bars, by the way, forgot to glossed over that really quickly, just to jump back once more. The absolute value bars are needed if the index is even. We'll take a look. We do have an even index. Again, the index was 2, so that's an even index. If the index is even and the variable under the radical has an even exponent, well, let's take a look and, oh, look at that. In the original problem, we had even exponents underneath the radical sign. Jumping back, the result of simplifying is an odd exponent. In reading this right now, I see I made an error with the answer, and that's part of doing all of this in one take. We have an even index. That index was 2. In fact, let me just change to a different highlighter color because this is a really important idea. Let's go to red's fine. The index is even. The original problem, we had even exponents. So don't even worry about the x. That x had a power of 1. In the final answer, if you have those two situations of an even index and even exponents, if in the final answer your exponent is odd, like the number 3, then your answer needs to have absolute value bars around it. Now, there are reasons for that could be talked about, but I'm not going to bore you with those reasons. I'm just going to let you know that is the situation you need to be in. Again, there is a reason. Maybe I'll talk about that in class, in person. But right now, for the sake of being able to do the correct work, learn the following. If the index is even, if the original exponents were even, but in the answer, the new exponent is odd, you have to put absolute value bars around that variable. You don't have to put the absolute value bars if the exponent is even, like the z has a 2. That's going to come up in a few more examples. It's the trickiest part of the lesson. Stay with me. Let's go ahead and do number 4. Simplify it first, and then come back and try those domain restrictions. I'm giving you a moment to pause and give it a shot. And all right, here we go. We are taking the square root, so we have an even index, very much like in the previous problem. We're taking the square root of 9, x to the 6th, y to the 4th. Well, that is very nicely set up to just simplify everything right now. The square root of 9 is going to be 3. We are taking the square root, so that's an even index, and we are doing that to 2 exponents that are also even. When we do 6 divided by the root, let me just change color, 6 divided by 2, we are going to get an x cubed. Because we got an odd exponent after doing the simplifying, we have to put that in absolute value bars. The y to the 4th, that is now going to also be hit with that index of 2. And when you do 4 divided by 2, you're going to get y squared. Because the power on the y is even, it is not going to get absolute value bars. The x got absolute value bars because the final answer had a 3, which is an odd number. I know that sounds tricky, so I'll try to highlight everything once again. If the index is even, if the original exponents that you're working with are even, if you're working with even exponents, and in the answer, the new exponent on that variable that you took out is odd, it gets absolute value bars. And if it's an even exponent, it doesn't. I know that sounds tricky, but hey, try to stay with me. The domain restrictions. We did not have a fraction problem, so that means there is nothing about the domain not being equal to 0. We didn't have a denominator in this particular problem. And we do have an even index, and underneath the radical sign, well, there wasn't anything left over. So you don't have to worry about anything radical-wise where it has to be greater than or equal to 0. The domain for this will put the fancy notation for domain showing all real numbers. Anything would work for the domain in this problem. Positive numbers or negative numbers, it doesn't matter. All right, let's go ahead and look at another example. Pause, try them. Remember, with a fraction problem, work from the inside out and use a little bit of power over root if you need to. I'll give you another moment. And all right, let's talk about number 5. So we are going to first work from the inside out, dealing with that fraction bar. We have a 16 over 2. 2 goes into 16 8 times. So start off with an 8. You have an x and then another x, and those x's will cancel out entirely, so there is no x in the final answer. You have the same base dividing rule, so your 6 is going to be subtracted by 3, and you're going to get a y cubed. Since there is nothing left in the denominator, the number 1 would just go there, and the square root sign would go on top of all of that. Now we can keep simplifying. We're going to have the square root of 8y cubed. That 1 can just go away. Remember that 8 can be rewritten as 4 times 2 because 4 is a perfect square. And y cubed is going to be rewritten as y squared times y to the first power so that we can take the square root. I hope you notice that because we have an even index, we're going to have some business involving absolute value coming up pretty soon. So let's finish simplifying. The square root of 4 is going to be 2. We are able to square root y squared, and it's going to come out as a y. But because that y has a power of 1, and 1 is odd, we're going to get absolute value bars around it. It doesn't happen just because the exponent on that y was a positive 1. It also happened because the original index was even. It was a 2. And then in our final answer, the y that we got had a power of 1, so it's going to get absolute value bars. Don't worry about y, just accept it and move on. What are we left with? The 2 and the y1 that are under the radical sign have to stay under the radical sign. So there we have our answer. Let's go back to that yellow highlighter. All right, and then the domain was restrictions. We did not have, or we did have, let's clear that right there. We do have a fraction in the beginning of the problem. We have an x and a y that are both in the denominator. That means x and y are not allowed to be equal to 0. Secondly, in the final answer, we had a y underneath a radical sign with an even index. You are not allowed to have a negative value underneath an even index radical. So that means y has to be greater than 0. Not or equal to, because we already said in the statement before that it can't be equal to 0, so it would technically be wrong to say greater than or equal to. You would just say y is greater than 0, and those are the domain restrictions. Number 6, last one. Again, try simplifying, or I think there might be a 7th problem. Yeah, there's a 7th problem. Again, try simplifying first, and then give those domain restrictions a shot. All right, here we go. So the 4th root, well, 8, the number 8, is not a perfect 4th, and there's nothing you can do to simplify it. So there's really no simplifying you can do to the number 8. The x to the 6th power, since there are 4 x's you can separate, then that leaves 2 of them left over. And then your y to the 9th, you can think of that as y to the 8th with a single y left over. And then z to the 10th could also be z to the 8th with 2 of the z's left over. And we did that because 4, 8, and 8 are all multiples of 4, and we are allowed to simplify the 4th root with those exponents. So the x to the 4th is going to come out as a single x. The y to the 8th, 8 divided by 4 is 2, and then z to the 8th will also come out with a z squared. And then everything else is stuck under the 4th root symbol, the 8, the x squared, the y to the 1st, and the z squared. And that odd-looking answer is the answer. Now for the domain, we'll put just a D for domain this time. We have an even index, and we have variables under the radical sign. But notice the x and the z are both being squared. Now, I've said before that if the index is even, then anything under the radical sign at the end of the problem has to be greater than or equal to 0. But the thing is, y is the only variable that needs to be greater than or equal to 0, because if x, theoretically, let's just say x were equal to -4, well, if you plug -4 in for x, you're going to be squaring it. And -4 squared goes to +16. Same idea with the variable z. If you said that z equals -2, well, you're plugging in a -2 to just square it. It is all right if you are raising a negative number to an even power, because that's going to come out as a positive answer anyway. So y is the only variable that needs to be stated as greater than or equal to 0, because y is currently to the first power. And that means if y were equal to a negative number, it's not going to be squared to make it positive again. And you can't take an even index of a negative number. I know that sounds very confusing, and it would probably help a lot more in class if you could see me pointing at things and writing things on the board in real time, but hey, this is the best we can do. Try to absorb the main idea, and if at the very least you can simplify, but you get the domain part wrong, well, it's not the end of the world. In number 6, we did not have a fraction problem, so we don't have to worry about any denominators. And let's just quickly check on absolute value bars. Did I make a mistake? We have an even index. We had let's see, an x to the 4th came out, and we have, a power and an odd index, right? An odd power right there. That x had to be in absolute value bars. And then in the other two answers, the y and the z, both of those had powers of 2. So we did not need absolute value bars in those situations. So there we have it with number 6. Let's go ahead and do one more of these and then call it quits. Number 7. A little bit of a negative exponent. Again, work from the inside out. Try to remember that negative exponent rule. Pause and come back when you're ready. And all right, let's just talk about it. So, working from the inside out, let's build that fraction answer. I see we have a 2 and a 3, but we can't simplify those anymore, so we can just write them down. We have an x squared, and that's going to cancel with 2 of the x's that are in the numerator. 8 minus 2 is going to be 6. We have a z to the power of -2, and because of the negative exponent, we are going to flip the z to the numerator, and then we're going to switch the exponent from negative to positive 2. And then the y to the 6th power, that's just going to stay put because there was nothing to cancel with it, and it's not going to move anywhere. And then we can just go ahead and move this number 3 to the middle and put the cube root sign over the entire thing. All right, we have simplified a little bit of what we can do on the inside. Let's now deal with that root being 3. And I see we have an x to the 6th and a y to the 6th. So both of those exponents are multiples of 3. So we can just cut right to the simplifying stage. The x to the 6th is going to come out of the radical as an x squared. 6 divided by 3 is 2. And then y to the 6th, that being cube rooted, you're going to get y squared. Everything else cannot be removed from the cube root sign. So the 2z squared stays in the numerator with the 3 in the denominator. And that is going to be the simplified answer. I see we have an odd index, so we do not have to worry about any absolute value bars with the front of the problem. You're going to notice that we had variables in the denominator. So when we set up D for domain, that means x and z are not able to be equal to 0 because they were in the denominator of the original problem. And then in the final answer, I see we have a z, but it is being raised to a positive and even index. So that means it could be negative. You could have a negative value for c and square it, and your index is odd anyway, so that actually doesn't even matter. X and z cannot be equal to 0, and that would be the domain restriction. All right, I think that was the last problem there. Yes, and then there was just a few more practice problems here for you to try. But this video has gone on long enough. There will be some practice associated with this online as well. Hope these higher level problems were things you could keep up with. And again, if this was over your head in terms of comprehension, you need to go back to some of the previous lesson videos and just skip to the examples where a lot of these simplifying tips are done with a little more of a pace to it, with a little more of a slower pace to it. And again, the focus of this video were the domain restrictions and taking you through some higher level radical problems. Thanks for watching, and I will see you next time.